Hi, in this video we're going to be talking about the perimeter and area of similar figures. What's cool is they've got this proportion of k or k squared. So right here we've got two figures. Um, they've got a side that is 2 versus 4. If we look at their perimeters, the perimeter is the distance around this shape. So the small one is 2 plus 2 plus 2 plus 2, which is 8. And the big one is 4 plus 4, which is another 8, and another 8. So that's going to be 16 if we go around that figure. And then the area of these two figures, the area of this one is 2 times 2, which is 4. And the area of this one is 4 times 4, which is 16. What we find is that the ratio of small to big in this one is going to be 1/2. 2 divided by 4 is 1/2. When we do that same thing with perimeter, we get the same ratio. 18 divided by 6, that is 1/2. If we do that with the areas, 4 divided by 16 is not 1/2. 4 divided by 16 is 1/4, but that 1/4 is the same as 1/2 squared. So that k is the same as what we had up here. It is just being squared. So here, our ratio and our area, it could be considered k squared. But then we wouldn't call this K. We'd call this some other one, W or whatever. So ratio of our area is K squared, and everybody else, the ratio stays the same. So in this example, I'm not given the actual figures. I just know the ratio is 3 to 1. So if I do their sides, I know that just their sides is going to be 3. That would be our ratio there. For our perimeter, the ratio is going to stay the same as it was for the side. So our K is just going to stay as a 3. For the area, however, we just got to square that 3. So area is K squared. So the ratio of our areas is going to be 9. Here again, I'm given some figures, so I can figure out the ratios smaller to larger. So this is my smaller one and my bigger one. So my k for these two figures has got to be smaller to larger. So I'm going to do this 5 divided by 15. I could have done the 6 and the 18. That would have worked too. So then my k will be 5 divided by 15. That's 1/3. So the ratio of my perimeter is going to stay the same as it was for these sides. It's still going to be 1/3. For the area, however, I've got to change it. The area, I've got to do 1/3 squared. So that's 1/3 times 1/3, which is 1/9. So this should be the area of smaller to larger for those triangles. Now in this example, I'm given the area of two figures, and I want to know what their similarity ratio is. So I know that whatever their similarity ratio is, k squared, that has got to be whatever the ratio of their areas were. So that is 27 over 48. I could simplify that fraction by dividing top and bottom by 3. So k squared equals 9 over 16. But the similarity ratio between these two should just be k, not k squared. So that's telling me I've got to square root both sides so that I can get that k by itself, and I'll know the similarity ratio for the two figures. So k is going to equal the square root of 9 over the square root of 16. So that is 3/4. So this is the ratio between the two figures. And a reminder for perimeter, we don't have to do anything. Perimeter is going to be the same as the ratio between the two figures. So the ratio of their perimeters should be still 3 to 4. Let's try that one more time. So k squared is going to be the ratio of these two. They didn't tell me which direction they wanted to go, so I'm just going to go in this order. It doesn't matter, just as long as you're consistent. So 75 over 12. So that's 75 and 12. I can divide both those numbers by 3 just to kind of simplify my fraction a little bit. So I know k squared is going to be 25 over 4. But that is not the similarity ratio of the figures. I've got to square root both sides. So k has got to equal the square root of 25 over the square root of 4. So that ratio is got to be 5 over 2. So this is the ratio of the figures for the perimeter. The ratio of the perimeter is going to be the same as the ratio of the figures, so the perimeter is ratio is also 5 over 2. Now in this one, I know these are similar, and I got one of the areas, and I got to determine the area of the other one. So the first thing I want to know is what is k between these two shapes? And I can do it in either order. I'll go left to right. Doesn't super matter. You just got to pick a direction. So that's 3 over 6. So that means my ratio of the figures is 1/2. Then I need to know what k squared is because that's going to give me the proportion of their areas. So k squared is going to be that 1/2 squared. And 1/2 squared, I know 1/2 times a half is a fourth. So to find the area of the smaller pair, if I know, so to find the area of the big one, I need to use the area of the small one. Now I did small to big. Small to big. So I better do this next proportion as small. So that's 6 to big, which I don't know. So I'll call it x. I know that this ratio has got to equal this ratio that I just got. So this has got to equal this 1/4. So now that's a little proportion I've got to solve. First thing I want to do is I don't like that x is in the denominator, so I want to get that out. So I'm going to make this x over 6 equals 1 over, oh, nope, sorry, 4 over 1. My bad. So x over 6 equals 4 over 1. So then to solve for x, all I need to do is multiply both sides by 6. So x has got to equal 4 times 6, which is 24 divided by 1. That's just 24. So it's 24 inches squared. That should be the area of this guy. Well done. And that is it for our video on similar perimeters and area. A reminder that similar figures, the ratio is k. The perimeter is still k, and if you do that area, it just squares whatever you had for the sides of the perimeters. Thanks so much for watching. Bye-bye.